So today we are going to see the digital design of a seismometer. We are going to use a tilt sensor that Tinkercad has in here. And of course Arduino Uno. So how we are going to start working here is by going to this search area and typing Arduino Uno. We are going to use the Arduino Uno microcontroller. So we are bringing this component to the left. This is going to be our workspace. Also, for this project, we will need a breadboard for the wiring. So we are bringing this one a little bit at the bottom of the Arduino microcontroller. Our next component for the alarm is an LED. And this LED will need a resistor, so we are bringing also a resistor. Then for sound, we are bringing a buzzer. We will need also a tilt sensor. This tilt sensor will use also another resistor. We will change the value in a few minutes. And for the door, we are going to control the opening and closing of a door, a micro servo. So we are bringing micro servo to our workspace. So we have our components for this digital design. Now in here, the resistors, we click on them, they are coming in 1 kilo ohm. We need to change this one, which is gonna be for the LED. This one changes to 220 ohms. And the one for the tilt sensor has to change to 100 ohms. Okay. So we have our resistors ready. This project requires 5 volts and ground. So our next step is doing the wiring from the Arduino microcontroller to the breadboard. So this section is the 5 volt. We are going to click and draw a cable to the red area or red line of our breadboard. This one is the 5 volt or the positive. We can click and go into this section and change to red. So that way we will know that 5 volt is the red cable. Now for ground, goes to the blue rail and then click, and let's change this one to blue. This one is gonna be the blue cable representing ground. So that way we will have all this rail as ground and all this as positive for 5 volt. So let's build the alarm. We are bringing our LED to our breadboard, and we will place it here on the F row. And then let's take a look to the pins, because LEDs, they have polarity. So the first one, which is the cathode, this is the negative pin of our LED. So we will bring 220 ohms resistor, and this one is going to be connected to the blue rail of our breadboard. So what we are going to do here is bringing this, connecting from blue rail to the cathode of our LED. This second pin is our anode or the positive, and in this case we are going to connect this to the digital pin in our microcontroller. This one is going to be a number 10. So let's look for our number 10 digital. which is in here. What we are going to do is click and let's change to red, so we will match the color of our cable with our LED. By clicking twice, we can bend this cable, and we can move this cable to the position we wish. So it can be like that. Now our second component is gonna be the tilt. So let's bring our tilt in here. We need space because we will use a resistor which goes horizontal. So let's take a look to the first pin, which is the terminal 1. This is gonna be a connection to our blue rail in our breadboard. So let's draw a cable to the blue rail. For controlling the values on our tilt sensor, we will need the 100 ohm resistor. So we're bringing this, then going up left, and we're going to rotate our here component horizontally, and just making sure that this pin of terminal 2 goes connected to this section of the resistor. So now from here we are going to draw a cable to our Arduino. In this case it's going to be an analog pin. So let's look for an A0, analog 0. So in here, let's change the green. So we already have our analog connection ready. The second part of our resistor is going to be the connection to 5 volt or red rail in our breadboard. So from here, let's draw a cable to the red rail, changing this to red to indicate that this is a connection to 5 volt. So our tilt sensor is ready. The next is our buzzer. So let's bring the next component. We are going to rotate, so the pins are going to be facing to our microcontroller, and let's look for the polarity for the pins of this buzzer. This one, for example, is the negative. Negative goes to the blue rail in our breadboard. So let's change this to blue to indicate ground. Second one is the positive. So this one is the connection to our microcontroller, and in this case we are going to pick number 6. Number 6 digital. So from here we are going to draw a cable to this section. We can change the color of our cable, so that way we have this cable connected to our Arduino. The next component and last is gonna be our micro servo. So we can bring this to the left, rotate. Let's place this one in this section. It's gonna be, the wire is gonna be easy. So this micro servo has polarity as well, so we need to take a look to the pins. This one, for example, is our ground. So let's draw a cable from here. Let's look for the blue rail on our breadboard, and let's change color to blue. There is a difference in the wiring of our micro servo. So we have here two choices: changing this one to blue or changing to brown In this case brown, in this kind of servos is ground. So we can leave this one as blue, or we can change this one to brown, to blue for ground. So the next one is gonna be power. So we need to draw a cable to the red rail for 5 volt. Changing this one to red. Our last is the signal. Usually is the yellow cable, and this is the connection to our microcontroller. So in here we are going to look for number 11. So what I can do here is clicking on the LED, separating the cables, so we can see here this connection. This is the number that we need for our servo. If you see here, it has a tilde, a line next to the number. This is a special pin that can handle many numbers, like in the case of the micro servo that has from 0 to 180 degrees. So let's draw a cable from signal to number 11. This one is gonna be our yellow. We can click twice and bend our cable. We can design our wiring in a way that is not interfering with the other connections. So basically we have here our wiring ready. The next thing is typing our code. So we are bringing this prototype a little bit to the left. So for using the simulation, we need to type the code. So that is going to be our next step. In our case, we are going to use text and continue. This is the type of language we are going to use is C++. We erase this section because we are going to type our own code. So the first thing is going to be the declaration of variables, and we are going to start with defines. This define can be, we can call this, which is going to be the LED, can be LED red, and this one is connected to the number 10. So we need to specify the pin. The next one is gonna be another define, another variable, and is our buzzer for sound, and this was a connection to number 6. The sensor is going to give us values from 0 to 500, but we are going to use a whole number, which is int or integer. We are going to give a name sensor value, and we are going to start reading this sensor from 0. Also, we have Servo, which is going to be another variable that we are going to be using here. In this case, is an include because we are using a library. This library is the classic servo.h. We can omit spaces to avoid errors. This library must have a name, so we are going to call this library servo my servo, closing with a semicolon, and that way we have our 5 variables already set. The next thing is our void setup. Void setup is for starting all our, in this case, the serial monitor. Since we are going to be using this section of our Tinkercad, we need to use the serial begin, which is a reading of data. The speed of this data is at 9600 baud for reading this section. And then also inside this void setup we need to include the pin modes or the connections to our Arduino. The first pin mode is gonna be our sensor. So in here we need to take a look to the connection to our sensor, which was pin mode and then analog 0. This analog 0 is an input. The information the sensor is bringing data to the project, and then we have another pin mode, which is the LED. So we need to take a look here the name that we gave to our LED, which was LED red. So we need to type that and indicating what type of connection or component is this. So this one is an output opposite to the sensor. Also we have for sound another pin mode. This pin mode has a name, which was buzzer, all in capital, and this one is another output. Data being released from the project. And the last one is the connection to our servo. So in here we gave a name to the variable, so we are going to do the same, my servo. Then we need to include a reserve word, which is attach, and the connection. So the yellow cable is 11, so we are going to add 11 as the pin we were using. And we close with a bracket our void setup. The last part of our project here is the void loop. Void loop is the function of our digital design. In here we will tell what do we want to do inside our project. So the first thing is reading or finding the pin of our sensor. So in here we type the name of the variable sensor value. So we are going to use it again, sensor value. And what type of connection is this? This is a digital read connected to analog 0. Then we are going to multiply this one for 500 because we are going to use the serial plotter to make the plotter a little bit higher in the wave. And then we need to see this data printed in the serial monitor and the serial plotter. So that's why we are going to use the command serial print quote space quote, and in here this value is going to be printed to the serial monitor and serial plotter. Then we need to write serial print in another line, so ln, and the sensor value is going to print the number 0 or 500 depending the position of our tilt sensor. So what are we going to do with this number? So we are going to open a conditional statement if sensor value is let's say less than 500, closing and opening with a bracket, what is going to happen to our LED? So our digital write it's gonna be LED red is gonna be on, so high. What is going to happen to our buzzer? So this one will have a tone, which is the name of the variable is buzzer, and the frequency in hertz is 900. Of course, you can modify this number. And this is just an example of the frequencies that you can use. So frequency in hertz. So we have 900. Then I'm gonna start with my servo, the variable my servo. We are going to write an angle, and this angle is gonna be at 0. And then we will have a timing between all these functions. So this one is gonna be 50 milliseconds. C++ understands delays as milliseconds, so every number that you put inside the parentheses is represented in milliseconds. So we close the first conditional statement of if, and closing with an else. So my sensor value, if it's greater than 499, what is going to happen to the rest of my components? So the digital write is gonna be the first one, LED in red. This one is gonna be in low, closing with a semicolon. Also no tone. The buzzer is gonna be off completely. And the situation with my servo, I'm going to write an angle here of 180 degrees, which is the complete section or the complete angle in case of the micro servo. And then we close here with a bracket indicating that we close this section of the void loop. In here we have an icon for zooming the project, so we can click here, and this function is for actually starting the simulation. So if I start the simulation here, the program will check if we have mistakes. If we don't have mistakes, we'll start counting in time here. So the next thing is clicking on the tilt, opening the serial monitor, and opening the serial plotter. So we are going to modify this or move this slider to the right, and then we will see how the project works. So the value of 500 will represent no warnings, and then if we move to the right, also these values can be modified depending the type of project you want to build. So the next and last step is the engineering prototyping using Arduino IDE. There are going to be some modifications in what is the conditional statements. You can modify those in Arduino IDE depending how you want your project to work. Thanks for watching.